Okay, in continuation of what we've been dealing with derivative, and knowing that derivative is a way to find the value of slope, we're going to find the slope value for various tangent lines here in this particular lesson. We're on page 115, and we're looking at the odd number problems. We'll start with 31. The function given here is 3 over x squared, and we want to know what is the slope of the tangent at the point 1, 3. So I rewrite this so that it's 3 times x to the negative 2 power. Take the derivative of that. I should say of here. And this slope then becomes negative 2 times 3 is negative 6. Subtract 1 from this to get negative 3. Not negative 1, that's adding 1. We're subtracting 1 here. And then rewrite this in that form, we get negative 6 over x cubed. And since we're trying to find the slope where x equals 1, which is what we have here, we plug in 1 for x here, and we get negative 6 over 1 cubed, which is negative 6. So the value of the slope at the point 1, 3 is negative 6. Problem number 33. We have here, the function is this value right here. We take the derivative of that, where the point 0, negative 1/2. This is a constant, so the derivative of constant is 0, so that drops out. 3 times 7/5 is 21/5, and we subtract 1 from 3, we get 2. So this gives us that. Then we find the slope or the derivative at 0, plug in 0 for x, and everything becomes equal to 0. So that is a horizontal line at that particular point. We call the point where the curve becomes a horizontal line an inflection point, meaning it's going from positive to negative or negative to positive, depending on what's going on. You'd have to look at the graph to see that, but I think if you actually put this into your calculator, look at the graph, and at the point where x is 0, you'll see that that inflection is taking place. And that tells you horizontal line is slope is 0. For problem number 35, we're given 2x plus 1 squared is the function of x. Now, what I wanted to show here is how you can do this without doing the FOIL method. If you want to do the FOIL method, I don't really care. Just trying to save you a little time, but I know some people make the mistake of just squaring this and thinking that's all there is to it. But when you square a binomial, you're going to get a trinomial unless you're dealing with a difference of squares. But even if you square it, you're not going to have a different squares, so that's a whole other thing. Anyway, you square this, which is indeed 4x squared. You square 1, which is 1. And then you multiply these two together, and then double it, and then you do 4x. So this is the actual function that you're dealing with. That means that the derivative, 2 times 4 is 8, 2 minus 1 is 1, so the exponent is 1. 1 times 4 is 4, and 1 minus 1 is 0, so the x term drops out. This is a constant, so that's gone. So this is 8x plus 4, and we're looking at the slope where x is equal to 0. That drops out to leave us an answer of 4. For number 37, this is a little tricky one, but you have to think in terms of x. This is the best way to do this, at least particularly for this part. Now here you can't do that. I mean, or you could, but you're still going to end up saying, it's like if this was function of x equals 4 times sine of x minus x, then I think you'll understand what we're talking about here. When you do the derivative of that, since the 4 is multiplying here, not adding, that's not considered its own constant being added here. So we leave the 4 alone, and it's going to multiply by the derivative of this, and that's one of your laws or rules that you should have in your calculus toolbox. The derivative of sine of x is cosine of x, and then if this is x, derivative of x is 1, because the exponent 1 goes down front, and then it leaves it 0, because 1 minus 1 is 0, so that's 0, pi, or theta to the 0 power is 1. So this is going to be 1 times 1, which is 1. And since we're looking at the function of, or the derivative at 0, For this, then the cosine of 0 is 1, because it starts on top and then goes down. But 0 is at its maximum amplitude of 1. So 4 times 1 minus 1 gives us 3. So the slope of this equation at the origin is going to be 3. This next one is dealing with trying to find the equation of a tangent line. It starts off exactly the same way. You go through and find the derivative for this. 4 times 1 is 4. 4 minus 1 is 3. 2 times negative 3 is negative 6. 2 minus 1 is 1. That's a constant that drops out. Then find the slope value where x is equal to 1. Then you're going to put in 1 for both of these, and you end up with 4 minus 6, which is negative 2. Now we're being asked to find the derivative of the tangent, or of the equation of the tangent line at the point 1, 0. Well, 1 is your x and y is your 0. And we're going to use a variation of y, or m equals y2 minus y1 over x2 minus x1. In that, we're going to make y2 the general y and x2 the general x, and the y1 and the x1 coming from this particular point that we're finding the tangent of. So we plug that in and we get this, y minus 0, which is y on top, and x minus 1 on the bottom. Cross multiply, negative 2 times this and 1 times this. 1 times y is y, and negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So there is the equation of your tangent at the point 1, 0 of that equation. And finally, the last problem that we're going to do is a little tricky, at least in what it looks like, but it really is nothing different from what we've done. We're given this problem right here. This is x to the 3/4 power. This is cubed, and you're taking the 1/4 power of that. When you take a power of a power, you multiply them. So this is x to the 3/4 power. So it'll be 2 over x to the 3/4 power, which we can rewrite as 2 times x to the negative 3/4 power. So when we find the derivative of that, we take negative 3/4 times 2, which is negative 3/2. And then we subtract 1, which is the same thing as adding a negative 4/4. And negative 4 and negative 3 is negative 7, so we get negative 7/4 for our exponent. Then we plug in 1. Well, the nice thing about that is 1 to any power is 1. So that's negative 3/2 times 1, which is negative 3/2, and that's going to be our value of m. And again, this is going to be x1, and this is going to, x1 is y1, and then y2 and x2 are going to be generic x's and y's. We're going to get negative 3/2 equals y minus 2 over x minus 1. We cross multiply. This gives us, and I like to keep the negative with where the x is, because we want to end up with a positive y, and the less we have to do with negatives at the end, the better. So negative 3, or I'm sorry, positive 2 times y minus 2 is 2y minus 4. Negative 3 times quantity x minus 1 is 3x plus 3. And then we want it yet in the form of y equals mx plus b. So that means we've got to move the negative 4 to the other side of that positive 4. And that gives us 2y equals negative 3x plus 7. And then you get rid of the 2 with the y, so divide everything by 2. And we get negative 3/2 x plus 7/2 is our equation of the tangent at the point 1, 2. It looks complicated, but it's not. It really makes a lot of sense if you keep in mind what the median slope is. And as we go through this course, we just have to keep reminding ourselves of that particular point when we're dealing with the slope aspect. When we deal with the area aspect, we'll talk about that later on. With your practice problems, page 115, 32 through 38, 54, and 56. Okay? Good luck.